In a relay race, there are 5 teams A, B, C, D, and E. What is the probability that A finishes first, B finishes second, and C finishes third? Pause the video, give this a try. Okay, so let's do this together. We care about who comes first, second, and third. We don't care about the fourth and fifth. Let's call them winners, first, second, and third winners. What's the total number of ways in which our winners can be arranged? There are 5 ways to select who comes first. Then there are 4 ways to select who comes second. And there are 3 ways to select who comes third. 5, 4, 3. That's 60 ways. 12 times 5, 60. So there's this list of 60 arrangements from A, B, C, and D of first, second, and third winners. And out of these 60, only one has the order A, B, C, where A comes first, B comes second, and C comes third. So favorable way is 1, total way is 60. The probability is going to be 1 over 60. Here's the next one. What's the probability that A, B, and C are first 3 to finish? In this case, the order doesn't matter. We care that A, B, and C are winners. We don't care who comes first, second, or third. Try this on your own. Okay. So if the order doesn't matter, A, B, and C can be arranged amongst themselves in 3 factorial ways, and they can still all 3 be winners. 3 factorial is 6, which means there are 6 such arrangements where we have A, B, and C winners. All of these arrangements work for us. So probability of A, B, and C as first 3, that's going to be 6 upon 60. That's going to be 1 by 10. Here's the next one. What is the probability that A finishes in top 3, but B doesn't? Pause the video, try this on your own. Okay. So we need to figure out the probability of this and this, these 2 events happening. Both of them have to happen. A has to finish in top 3, which means A is a winner, but B doesn't, which means B is not a winner. If we rank people in this race, we have first, second, third, fourth, and fifth, these 5 positions. A can pick any one of these 3. A has 3 options. A could be first, second, or third. Whereas B does not win, which means B has 2 options. It could be fourth or fifth. What about C, D, and E? Well, they can arrange themselves in the remaining 3 slots. That can be done in 3 factorial ways. So what's the total number of favorable ways? That's going to be 3 times 2 times 6. 3 factorial is 6. 6 times 6 is 36. And what's the total number of arrangements? 1, 2, 3, 4, and 5, which means 5 factorial. That's 120. So the probability of this happening, that's going to be 36 upon 120, which means 3 upon 10. That's 30%. Here's the last problem. What is the probability of both A and B winning and A performing better than B? Pause the video, try this out. Okay. So we're given that both A and B are winners. A performs better. Here's a way to think about it. We can select our third winner in 3 ways. From C, D, and E, we can pick one to be amongst A and B as one of the winners. That can be done in 3 ways. Suppose our winner is X. Now in how many ways can we arrange our winners? Note that we want A to be performing better than B. That can be done in 3 ways. Here are these 3 ways. We can have A performing best. A could be first, and then B, and then our third winner, A, B, X. Or we could have A, X, B, or we could have X, A, and B. In this one, someone else comes first, A comes second, and B comes third. These are the 3 ways. So what's the required probability? That's going to be 3 times 3, 9, divided by total number of arrangements of winners. That's 60. So that's going to be 9 over 60 or 3 over 20. That's the probability of both A and B winning, where A performs better than B.